This is Scott from KIG. It is January 30th, 2020. Today we're going to do 2 or 3 runoff videos of this nice 7.5 ton cold shot air-cooled glycol chiller. This one is going to go to a brewery, so we've done some modifications to make it run at brewery temperatures, which I'll talk about in a bit. This is the model ACWC-090. And it's the serial number M0507113-1. It's a 230 volt, three-phase machine. So we've been running this unit for about a week or so. All is good on it. A couple things. We actually had the luxury of having a parts machine in back that had a slightly bigger pump, and the pump, when this came in before refurbishment, was in okay condition, but we took advantage and we put on a bigger pump. So this has a 2 horsepower centrifugal pump now, which for its brewery application will be helpful, and that's been run, tested. Seal is fine. What we also do is we modify the controller settings and pressure switch settings if needed, so we can go down to 28 Fahrenheit on the temperature controller. And then lastly, what we do per Cold Shot's guidelines for a glycol chiller is we modify the piping and we add a additional or a different return. So this is the in to the chiller, bottom here. As you can see, it goes directly right into the tank of the chiller. The old outlet actually is capped off here, so we actually have this bypass line. Okay, it doesn't go to the old connection here. This bypass comes directly back to the chiller, and where that flow switch is going into the chiller's heat exchanger. So again, the pump draws from the tank, okay, and it goes to this first pipe here. It goes out to your process, so this middle connection is out to your process, but it splits it off right here, and the other half of the flow, if you will, goes directly back to the heat exchanger in the tank. And so we'll talk about this bypass in a second. It's very important to have this open up just enough so that flow switch is made. We don't want it opened up so much that we're not getting enough flow going back out to your process. So over here we have our compressor. On the bottom we have our refrigerant sight glass for monitoring, our high pressure reset switch, hot gas, which in this case the hot gas, the variable speed fan drive, and this thermostat switch here is all working in conjunction for low ambient. Depending on what the temperature is, the low ambient will be functioning as a fan switch control or off of the fan speed control. And obviously we have all the covers on the unit here. The incoming power, we just have our test line coming in here. The incoming power comes to your main contactor here, and it's 3-phase. So if it is the wrong phase initially, the nice thing is we have a phase monitor, so you will not get that green light that you see here if upon initial power up you have the wrong phase, because it is phase dependent. This unit has an optional remote control box, which will give you a red light if there's any error, on off, and a green light if it's operating. That is a 1, 2, 3, 5 conductor cable. We just have a short section here, so if you want to use that, just get any 6 conductor cable. You can run it 20, 30, 40 feet, whatever, into the building. It's a nice option to take advantage of. If you don't use the remote, then right there where terminal 1 and 2 is, you'll have to put a jumper there. You see where that red and white wire is on the left? Put a jumper there, and then disconnect all these wires, and the unit will run. What else we have in here? We have the controller transformer. You don't have to worry about that, but depending on what your primary voltage is. Usually it's set up for 220 to 240 on the primary, but if you have 200 or 208 volt three-phase, then switch the tap so you can see one of them's capped off, and it'll give you little instructions on, tough to see, on the inside of the transformer how that wiring is. So we're going to go ahead. We already have the remote box on. We're going to start by just turning the pump switch on. And you can run it just in pump only. Sometimes that's good on a cold start morning just to get things going. Or put it in actual cooling cycle mode. So right now we have the tank heated up to about 74, 73. So when you're setting this up, the bypass is important here. Now see, if I throttle the bypass down too much, you'll hear the unit click off. Actually, I think it's already off. I'm going to open it up. And I opened it up and the flow switch was made. When the flow switch was made, my green light is on. Now you can see when I'm tightening up the flow too much, go into the flow switch. I'm tightening it. You can hear a click. I'm tightening it. Tightening in the wrong direction. Tightening it. And you can see my flow switch is not made there. Now I'm going to open it back up. My flow switch is made. So when you're adjusting this, you want to get your worst case condition. The worst case condition is when all your tanks are calling for cooling. All the solenoid valves are open, okay? And you want to start opening this up until you hear that click, okay? And that's giving you the minimum amount of flow under the worst case condition to activate that flow switch. If I open it up too much, then I'm not going to get enough flow going out to your process. You want to keep it kind of tight. So what we're going to do here is we're going to start chilling. All you do is you press the function key once, set point. I'm going to press the down arrow. We'll run to, let's say, 28. I press the function button again. And the chiller just turned on, or the compressor just turned on, and we're going to start chilling. And it's going to run down to a degree or two below the set point, and it's got a differential about 4 or 5 degrees. And so that means it'll go 2 or 3 degrees above the set point before the compressor kicks on again. So I'll come back to video number 2 in a few minutes here.